All right. On the triangle supplied, label the following: base angle, base, apex, altitudes, and vertices. Okay. So down here is our base. Is that okay? So if this is our base, and these are two angles down here, these here, two here, are our base angles. The very top of the triangle is called the apex. Now, this is important. When we're looking at our altitude, okay, we're going to have to draw a line at 90 degrees from the apex straight down. So that's perpendicular lines. This here now is our altitude. Okay, so it's very important when we're looking at the altitude that it's measured along a vertical line. Okay, the altitude there, it's measured along a vertical line. And so then any of these points out here are your vertices. Vertices also a vertices. Can you identify which angles are equal in the drawing below? So what I'm going to do, remembering our little Z shape, okay? So we can see whatever angle this is in here. Let's give it a name A. Then this one here has to be the same. Is that all right? Let's say that was maybe 60 degrees. Then A has to be 60 degrees as well. Is that okay? Look over here then. What else do we have over here? Another Z shape. So we'll call this C, C. Let's say this is 30 degrees. Then C down here has to be 30 degrees as well. The next question then, look at the sum of the three internal angles of any triangle is equal to what? 180 degrees. So if this is 60, this is 30, what angle has that got to be in there? How would we figure it out? So we'd add the two of them together. 60 plus 30 will give us 90. 180, take away 90 will give us. So that angle there and there has to be 90 degrees. And therefore, that's why the three internal angles have to add up to 180. And these are alternate angles. So if this is 60, this is 60. If this is 30, this is to be 30. Is that okay with everybody so far? Let's have a look at this one now. Identify the exterior and interior angles of the given triangle. Explain the following. The exterior angle of the vertex in a triangle equals to the sum of the two opposites. So, in plain English, this here, right? If we add this here, if we add this and this together, so we'll give these names A, B, and C. So if we add the angle A plus the angle B, they're going to equal to this angle D. I will explain why that is now in a minute. So if we get our protractor, we measure that angle there. It's giving us 60 degrees. Okay, so B is 60 degrees. We go over here, we measure this angle here, and it's giving us 35 degrees. We know now from the previous question that we can add 60 plus 35. It's going to give us 95. 180 minus 95 is going to give us 85. Okay, so that angle up there has to be 85. Now, how do we figure out the angle D? Well, this here is a straight angle. So it's 180 minus 35, which is going to give us 145. That angle D has to be equal to 145 degrees. If we add 85 plus 65, what's that going to give us? 145. So if we add these two angles together, they have to equal to that external angle. Is that okay? Because basically we're taking this away from 180, and whatever's left here then has to be equal to that angle right there. So in this question, we're asked to determine the measure of each angle A to F. So we're going to do a bit of maths here. So angle A, this angle here, plus this angle here, plus this angle here, we know has to equal to 180. So these three here, added these three together, have to add up to 180. If we add 80 plus 60, what's that going to give us? Is equal to 180. We're going to jump and change. So if this jumps over across from here, it's going to be 180 minus 140. A, therefore, is going to equal to 40 degrees. This one here now. What shapes are we looking for here? Our little Z shapes, aren't we? So if we could see from our Z shapes, alternate angles, what does B have to be? 46 degrees. Is that okay? And then our alternate angles again, C has to be 70 degrees. How do we determine D?
46
So 46 plus 70, which will equal to, what did you get? 116 degrees. We take 180 away from 116, and that'll give us 64 degrees. So therefore, D has to equal to, let's have a look at this here. What is that there from there to there? 180. So if we add 130 plus F is equal to 180. F is equal to 180 minus 130. We're jumping this across. F therefore has to equal to 50 degrees. Is that okay with everybody?
Yep.
So now we know that that there and there is 50 degrees. What is this symbol telling us? 90. That's got to be 90. What do we know now if we add this, this, and this? What should it all add up to? 180. So we're going to go 90 plus 50 plus E is equal to 180. 90 plus 50 will give us 140. E is equal to 180 minus 140 because we're jumping this across, so it's becoming minus. E therefore has to equal to 40 degrees. In this question here now, we're asked to fill in the label for each angle by selecting from the list given. So we've got names up here: isosceles, right angle, acute, equilateral, obtuse, angled, and scaling. So we've basically got to name these here. Okay, let's have a look at this. We'll do the first three. What's this one here? Equilateral. Okay. E Q U-I-L-A-T-E-R-A-L. So it's equilateral. So we can kind of get rid of that there one there. What does it mean by equilateral? All sides are the same. So you can see that they put in these little markers to show us that. And all angles are the same. And also all the angles are equal to 60 degrees. What's the next one? Isosceles. And again, it's telling us what? Two sides and two angles are equal. What about this next one? Scaling. Sorry, we've got isosceles done. Scaling.
You also put number.
You could, there's this one here and this one here, pretty much the same, except mirrored around, okay? So scaling, what do we know about the scaling? No angles or sides are the same. Okay? The next one then, so what's this one here?
Right angle.
Right angled. And this here, the hypotenuse is always opposite the 90 degrees. And it's always the longest side of a triangle. And you'll be using this later on, sine, cosine, and tan. All right, you'll be using that a lot in maths. So what is a right angle triangle? It's a triangle with a 90-degree angle in it. Is that fair enough? This one here, you could put down scaling again. All right, so you could put down scaling for this one, or it's acute angled triangle. What do we mean by acute angled triangle, do you think? All angles are less than 90 degrees. What are we scaling? Acute angles, right angles. So what are we left with just then? Obtuse. Angled. What do we mean by that? One angle is greater than 90 degrees.